So, welcome everybody to today's video, which is a little different than usual. And in this one, we're gonna talk about a puzzle and graphs. Yeah, and I'm not talking about the graphs of functions. Everybody knows them like that. No, I don't want the graphs of functions. No, I'm talking about these graphs. Yeah, a graph in math is a set of dots that may be connected by some lines, by some segments, because they can represent lots of situations. For example, social networks are graphs. In a social network, everybody is a dot. I'm a dot, and my friends are dots. And connections, lines connecting dots, represent friendship. So you can represent a social network with a graph, and then you can study the properties of graphs and try to understand your social network. And there are many examples of graphs. For example, the stations of the subway. When you represent them in a map, you know, the classical maps of the subway with all the red lines and blue lines, etc., and all the stations, all the little dots representing the stations, that map is a graph. So let's get started with today's puzzle and let's see what it has to do with graphs. And in today's puzzle, we have a sphere with some ribbons on it, with some streets, let's say, and we have an ant in position A. And the ant walks this way, in the way of the arrow, that way, yeah. And when it reaches the next crossing, it turns to the right, like this. And then when it reaches the next crossing, it turns to the left, like that. And it keeps on turning to the right and to the left, to the right and to the left alternatively. And the question for you is, after how many quarter circles will the ant return to point A? So, pause the video if you want to try to solve it, or keep on watching to see my solution. And for the solution, let's first try to solve the puzzle in the sphere, walking on the sphere. Let's see if we can understand what's happening. So we walk this way, then we turn to the right, we go there, and then we turn to the left, and then we turn to the right, and then we turn to the left, and I'm lost, I don't understand anything, I don't know if you understand what's happening, I don't, and then we turn to the right, I think, yeah, and we get back to point 8. But I didn't understand anything of what happened, did you? And maybe we can remove the white sphere to understand better, and let's just look at the ribbon, but that's not any more clear. So let's try with a graph. Let's begin by representing one of the streets with a circle, and then there's the point A over there. And then there are two streets that go through A, one vertically and one horizontally, and now here's the main focus point of this problem. If we start from A and we go in this direction and we go to the east over there, and if we keep on walking, we will reach a point which is diametrically opposite to A. Let's call it B. There's a point which is on the other side of the sphere, on the back side of the sphere. Let's call it B. So if we keep on walking to east, we will reach that point. But I don't want to draw point B behind A, because otherwise I'm drawing a sphere again. I'm gonna draw B over here, which is easier. So if I walk to the north and I keep on walking, I go past the North Pole and I keep on walking, I'll reach point B even from there. So if I walk north, I reach B. Yeah, that way. I don't care if that's not the way a sphere is really in reality. I just want to know which streets connect which points. If I go south and I go past the South Pole, I will reach point B even from there, like that. Yeah. And if I go west, I'll reach point B even from there. And so this is a graph that represents our situation. But perhaps we can make the graph a little bit nicer, and because if I move the point A a bit, we can recognize the three circles. You see there, the three circles over there, and I can make them more clear like that, and I can make the drawing even more symmetrical like that. So I have three circles with all the crossings. So let's try to solve the puzzle on this graph. So we start from point A and we take a street like that, and on the next crossing we turn to the right, over there, and then we turn to the left. It's easy to understand where's the left, over there, and then we turn to the right, like that, and to the left, and to the right. So in 6 steps, we get back to home. And in our case, it was useful to visualize something that was difficult to visualize in 3D. Okay, that's it. Hope you liked it, and I'll catch you on the next one. Ciao, ciao!